In the last video we saw why we would want to write our own overloaded assignment operator. Mainly the problem was once you use pointers, dynamic memory, once you have these things involved in a class, then you will want to avoid situations where you have shallow copies. So let me just take a look at what we saw before. When we do something like this, z is equal to y, and it's not because we're chaining things. Even a simple assignment like z equals y will copy over the pointer value from y to z. So even if you just had one assignment, z equals y, this problem would still be there. It's not a problem of chaining assignment operators. The default behavior the default behavior for assignment is to call the copy constructor, and you get a copy constructor for free, just like you get a default constructor. And what that copy constructor does is it takes the right hand side data member x, which is just an address, copies that address over to the left hand side data member x. So it just copies values from y to z, and what you get as a result is two objects, or in this case 3 objects, all with the same data member, all with the data member x pointing to the same array. And that's not good. They should be separate. They should always be distinct data members. You should not have things inside z pointing to the same things that y point to. In general, that's not a good idea, because if you change z, you change y too. That's not good. You can get all kinds of subtle bugs as a result of this one thing. And if you go a step further back, you may remember that if you make this a statically allocated array, that is, say, int x open close square brackets 5, nothing like this happens. So you don't need this. You take that out. You make this a statically allocated array. This works. You actually copy the contents. But once you start using pointers, once you start using dynamically allocated memory, all of these things become a problem. Okay, so then what you have to do is you need a member function. So you would need something that returns an ABC reference. All right, and you might ask, should we have a const reference that it returns? No, it turns out we should not be a const, and I'll tell you why. Operator. So remember that there was some concern when we overloaded the plus operator. We had to return a const reference. Now actually we don't want to return a const reference. And what goes into here, we have a left hand side is the object this itself, and the right hand side we can make it a const. ABC reference, let's call it RHS. Okay, and then the bare minimum you want to be able to do to satisfy the compiler is return this. And so what are we doing here when we say, so the way to look at it is, if you have a statement like x equal or y, let's just keep it simple. In the end, this will be used for something like z equals y. That would be the same as z dot equals y. Alright, and then this has to return something. This because you might want to chain it. You might want to chain an assignment. Z dot equals y equals x. Or no, actually this is what we really want to do. We want to chain something like this, and so this would be equivalent to saying y dot equals x, and then this returns the y object. So just ignore the z equals. Y equals x is the same as this, and it should return y. That's why we're returning star this. Okay, and then if you chain this, you're saying z dot equals that, this whole thing. All right, I hope that makes sense. Now, here's why you don't want to return a const. The whole reason is so that you can allow this to make this possible. Okay. If you make this possible, right? Not just z equals y equals x, but the quantity z equals y in parentheses equals x. Now, what you're saying is, this is a little bit different. You're saying z dot equals y, oops, dot equals y, and that whole thing will be assigned this value x. So that's when you put parentheses around z equals y, this is what you're really saying. And so that is another reason why you don't want to have this be a const, because if this were a const, you wouldn't be able to assign anything to it. Okay. So if you make this a const, this kind of assignment, this kind of chaining of assignments would not be possible. All right. So I hope that gives you some sense of why this is important. You need it to overload the assignment operator. Why do we need to overload the assignment operator? Well, you pretty much have to if you have this kind of thing. All right, what else do we do here? So the first thing we would do is we would need to find out how many elements there are in this array. And then the way I've set it up, I've made this a static array. Not static, sorry. It is a dynamic array, but it's fixed to just 5 locations. In the example in the book, they give you a better example where each object that they look at might have a different sized array, and so what they have to do in that case is they have to delete the array that's in this. They have to figure out how big the array in the right hand side is, create a new array of the same size as the right hand side, copy everything over. For our case, we don't have to do all that, and this is actually probably not the way it's done in the book is probably the way you want to do it. Here, I am assuming I'm restricting these arrays to be a fixed size. They're all size 5, so I can use this int I equals 0, I less than 5, I plus plus. Right? In general, you know this is not a good thing to do. So here, this is what I want to do. I want to do x sub I is equal to the x sub I in the right hand side. And that's it. Alright, so remember what the default behavior of the assignment operator is to copy the x value, which is an address location, from one object to another. So now if you let that happen, x, y, and z will all point to the same array. It's not good. To fix that, we define our own assignment operator. We overload it. And to do that, we have to make it a member function. That's just the rules, and I can go over that. Maybe we ran into that problem in 2 chapters ago, if you remember. So take a look in chapter 8. So this time around, we run this, and lo and behold, the array the array pointers are different, which is what we want. And let's see if we actually copied everything over. It should have been copied. We will now switch it back from getX to get, where we just print out the first value of the array, well, the value in the first location of each array, and now everything works. Alright, let's also check if this works. This should work. Should not get any compile errors. If we did, that means we are being too restrictive. We should be flexible enough to allow this to happen, even though technically it doesn't make sense to do this, but we should allow this to happen, and it does. Works exactly as it should. Okay, so that's a quick look at overloading the assignment operator, making a sort of a deep copy. It's not exactly a deep. No, it is a deep copy. That is, you're not copying the value of you're not copying the memory address from one object to another. So let me just point out By default, this is what happens. If you, whoops, by default, what the assignment operator does is x is equal to RHS dot x, and you don't have any of this. Okay, this is what, if you don't overload the assignment operator, this is what happens. You copy this pointer value from the right hand side to the left hand side, and as a result, when you do something like this or this, well, let's take a look at this. You copy the pointer value from x to y, and you copy the pointer from y to z. They all end up pointing the same thing. Not good. This is called a shallow copy. It's just not what you want. If you have a shallow copy and you have pointers, that's a big problem because you have multiple objects pointing to the same thing that was supposedly internal to each object. Instead, what you want to do is copy the contents over from the source to the destination, right hand side to the left hand side. Okay, so that's the whole reason why we did all of this.